So, good day, everyone, and we're gonna be solving this um, question right here using two methodologies. The first methodology would be the usual method that we use when we are being taught how to deal with complex fractions. And the other method that I'm going to be showing you would be a little bit on the creative side, um, or maybe not really creative, but we're not really used to using it when we're dealing with complex fractions. So hopefully you'll get to see um, the difference and also the similarities on how to handle such question, and hopefully this will give you a little bit more insight on how to deal with complex fractions. So let's go ahead and let's start with the usual method, wherein the algorithm starts with finding which one or which side of the equation will be a little bit more complex, and you start solving the more complex side. So obviously for this number, we're going to focus our attention here, and we're going to start with the bottom part of the complex fraction, which is simplifying 1 plus 1 over x. So let's go ahead and do that. So we're just going to use the method for simplifying fractions, wherein we're just gonna get the common denominator for this, which is x, and here 1 will turn into x, and then we'll have plus 1, and this is basically the same thing as 1 plus 1 over x. And then we're gonna go ahead and continue our algorithm, and we focus on this portion of the complex fraction. So we're gonna be rewriting. It's gonna be 1 over x plus 1 over x, and because we are dividing, our denominator, this part right here, will get the reciprocal of this, and will turn our operation into multiplication. So it's gonna be 1 multiplied to x over x plus 1, which is the reciprocal of our original fraction. And then we're gonna multiply it, so it's gonna be x over x plus 1. And then now that we have simplified this, we're gonna expand our algorithm. Then we focus on this portion right here. Okay, so it's gonna be 1 plus x over x plus 1, and then we're gonna do the same thing that we did. We get the common denominator, and then this will become x plus 1, and this will become x. So now we have 2x plus 1 over x plus 1. And now that we have simplified this, we're gonna go and simplify this entire thing. Okay, so let's do that. Okay, so we have 1 over 2x plus 1 over x plus 1. And then we're going to change this operation into multiplication, but we're going to be getting the reciprocal. So this will become 2x plus 1. And then this is x plus 1 over 2x plus 1. And then, now that we are done with the entire thing, we can now just do this portion right here. So we're gonna add 1 plus x plus 1 over 2x plus 1, and that's going to be 2x plus 1, then this is 2x plus 1 plus x plus 1, and then this will become 3x plus 2 over 2x plus 1. And now that we have simplified this entire thing, okay, we're going to equate 3x plus 2 over 2x plus 1 to 12 over 7. So let's do that. 3x plus 2 over 2x plus 1 equals 12 over 7. And what we're going to do is we're basically going to use the algorithm that we use for figuring out proportions, and we're going to multiply diagonally. So let's do that. So this will become 3x plus 2 multiplied to 7. Then the other one will be 2x plus 1 multiplied to 12. Then we're going to simplify everything. And this will become 21x plus 14. And then this will become 24 plus 12. And then we're going to combine everything that can be combined. So this will become 14 minus 12. And then this is 24x minus 21x. And then this will become 2. And this will become 3x. Then you divide both by 3. And then finally we'll be having x equals 2 over 3. Okay. And basically, this is how we usually do complex fraction. But I'll show you one method that we can do that's going to be a little bit different, and it requires you to understand fractions a little bit more. But I hope it will still help you. Okay. All right. So we're gonna be starting with the second methodology, which is which needs a little bit creativity, I guess, and understanding of the properties of fractions and how to deal with them. So let's go ahead and do that. So if you notice, these two, the left side and the right side of the equation, would be equal to each other. So that means whatever you do here will, you have to do it here as well, so that you maintain the balance or the equality. So the first thing that we can do is we can subtract this from 12 over 7. Let's go ahead and do that. Right. So since we will be subtracting 1 here, this will be 0. This will be gone. So the only thing that will be left would be this part right here. And then we're going to subtract 1 to 12 over 7. So let's do that. 12 over 7 minus 7 over 7, which is just equivalent to 1. 12 minus 7 will be 5. And then just going to copy the denominator. All right, so far so good. And then we have 1 over 1 plus 1 over 1 plus 1 over x equals 5 over 7. Now, since we know that this is our numerator and this is our denominator, we can just have the reciprocal of this. Okay, we can just invert this. If we're gonna invert this when performing division, we're gonna invert this as well. Okay, because like I said, whatever you do on the left side, you have to do on the right side as well to maintain the balance. So this will become 1 plus 1 over 1 plus 1 over x, because we just multiplied it basically to the numerator, which is 1. And then our right side will become 7 over 5. And then we're going to do the same thing we're gonna subtract 1 again here on the left side, and we're also gonna do that on our right side. Okay, so the only thing left here will be, the only thing left here will be 1 over 1 plus 1 over x, and then we're going to subtract 1 on the right side, so that's going to be minus 5 over 5. So 1 over 1 plus 1 over x equals 2 over 5. Okay, and then we're gonna invert again. Okay, we're gonna divide again this. Okay, so it's just going to be 1 multiplied to the reciprocal. Okay, which is going to be x over x plus 1. Okay, where did this come from, the x over x plus 1? It's just the simplified version of this. Okay, all right, so next, since we inverted the left side, we're gonna do that the same thing to the right side. Okay, so 2 over 5 will be 5 over 2, and then x over x plus 1 equals 5 over 2. And then we can just do the same thing that we did a while ago, which is getting the multiplying diagonally, similarly to what we're doing when we're looking for proportions. So let's go ahead and do that. So this is 2x, and this will become 5 times x plus 1. And then 2x here equals 5x plus 5. Okay, and then the next thing that we will be, oh, you know what, I have a mistake. I spotted it, and we're gonna go ahead and fix that one. Okay, all right, so let me fix first my mistake. All right, so here on this part, simplifying this will be x, and then this will become x plus x plus 1 over x. That's the answer for this one. And then we're gonna do the reciprocal, so it will be x over x plus 1 equals 5 over 2. Okay, am I doing it correct? Wait, you know what? Let me just do that. Okay, if I'm gonna invert this, so it will be 1 plus 1 over x equals 5 over 2. And then I'm gonna subtract 1 on each side. 5 over 2 minus 2 over 2. And then, okay, so this will be 1 over x equals 3 over 2. And then finally, if we invert this, it will become 2 over 3. Sorry, that took a little bit of time figuring out where I got the mistake, but we got there. So this is our answer. If you noticed, both methodologies arrived at the same answer. So hopefully this will help you out in dealing with complex fractions on your own. Let me know if you have other problems that you want to be solved, and we'll see if we can solve it together. Thank you so much and have a great day.